So, have you ever just stopped and wondered what you're really made of? I mean, not just flesh and bone or cells or even molecules, but the absolute most fundamental stuff of reality? Well, today, we are going deep. We're going to explore one of the most successful theories in the history of science, the Standard Model of particle physics.
Okay, so it all starts with something you probably remember from science class. You, me, this entire planet, everything is made of atoms. Just trillions upon trillions of them. It's a pretty basic fact, right?
But here's where things start to get really fun. Because as soon as you ask, well, what are atoms made of? You've just bought a ticket for a journey down one of the deepest, weirdest rabbit holes in all of science.
And that's exactly where we're headed first. We are going to peel back the layers of reality one by one.
You know, for the longest time, we really thought the atom was it, the end of the line. The word atom literally means uncuttable. But then, in the late 1800s, we found the electron. The atom had parts. A few decades later, we found a dense little core, the nucleus, packed with protons and neutrons. And just when we thought, okay, surely that's the bottom, in the 1970s, we discovered that even protons and neutrons are made of something smaller, quarks. With every step, the universe just got deeper.
So, with all these tiny little fundamental pieces running around, how in the world do we keep track of them all? Well, physicists have basically created a kind of periodic table for the entire universe.
It's called the Standard Model, and really, this is our best shot at describing all the elementary particles we've ever seen, plus how they interact with each other using 3 of the 4 fundamental forces. Now, which one does it leave out? Oh, just gravity. We'll get back to that one.
So the Standard Model splits everything into 2 main teams. On one side, you've got the fermions. Think of these as the bricks of the universe. They're the actual substance, the stuff that makes up all matter. And on the other side, you've got the bosons. These are the messengers. They're the particles that carry forces and basically tell the bricks what to do. So you've got bricks and messengers, matter and forces. That's the whole game right there.
All right, so let's start with those bricks. What is all the stuff in the universe actually made of when you get right down to it?
So even these matter bricks come in 2 distinct flavors. First up, you have the quarks. Their claim to fame is that they feel the strongest force in nature, the strong nuclear force. It's what glues them together so tightly. Then you have the leptons. You know one of these already, the electron. And their whole deal is that they're totally immune to that strong force. And that difference, it changes everything.
Now, if we look closer at the quarks, there are actually 6 types, or flavors, and they have these amazing whimsical names like charm and strange. And get this, everything you can see and touch, all the ordinary matter in the universe is made from just 2 of them, the up quark and the down quark. That's it. The others are like heavier, unstable cousins that only show up when things get really energetic.
And when I say heavier, I really mean it. The top quark, for instance, is an absolute monster. It's the most massive elementary particle we've ever found, by a long shot. Its mass is just staggering.
So what does that number even mean? Well, to put it in perspective, a single top quark has about the same mass as an entire atom of gold. Think about that. One fundamental particle weighing as much as an atom with 79 protons and over 100 neutrons. The subatomic world is just wild.
Okay, let's bring it back to something a bit more familiar, a proton. A proton, sitting in the nucleus of pretty much every atom in your body, has a really simple recipe. 2 up quarks and 1 down quark. Easy enough, right?
Well, here comes the twist, a huge one. If you actually add up the masses of those 3 quarks, you only get about 5% of the proton's total mass. Just 5%.
Which, of course, leads to a pretty mind-blowing question. If the building blocks themselves barely weigh anything, then what makes up the other 95%? Where does most of your mass actually come from?
And the answer is one of the most incredible ideas in all of physics. It comes from pure energy. The vast majority of a proton's mass, and by extension your mass, isn't from the stuff inside it. No, it's from the insane binding energy of the gluons holding it together, and this chaotic sea of virtual particles that are constantly popping into and out of existence. So, in a very real way, most of what you call you is actually the energy that's holding you together.
Okay, so we've met the bricks of reality, but they'd be pretty useless without the messengers that carry the forces. So now, let's meet the bosons. So there are 3 forces covered by the Standard Model. First is the strong force, carried by the gluon. That's the one we just saw, binding quarks like cosmic superglue. Then you have the electromagnetic force, carried by the photon. This one governs pretty much everything you experience: light, electricity, chemistry, you name it. And finally, there's the weak force, carried by W and Z bosons, which is responsible for things like radioactive decay.
And then there's the celebrity of the group, the Higgs boson. This one is special. The Higgs is the physical particle of a field that permeates all of space-time. And it's by interacting with this field, by kind of wading through it, that a lot of other fundamental particles get their mass in the first place.
So there you have it, the bricks, the messengers, the whole shebang. The Standard Model is unbelievably good at explaining our world. But here's the thing, it is not the final word. It's an amazing map, but there are huge parts of the territory that are just blank.
And this is where we see the edges of our knowledge. Remember gravity? The Standard Model has absolutely nothing to say about it. It doesn't explain the mysterious dark matter that's holding our galaxies together, or the dark energy that's pushing the universe apart. It can't even tell us the answer to a really basic question. Why are we here? I mean, why is there more matter than antimatter in the cosmos? It's a total mystery.
The first real crack in this beautiful theory came from a tiny, almost nothing particle, the neutrino. For decades, the model insisted that they should be massless. But then we discovered that they do have a tiny bit of mass. And not only that, they can actually change their identity as they fly through space. This was the first concrete proof that the Standard Model, as amazing as it is, just isn't the whole story.
So when you look at it all, the Standard Model is the most precise, most accurate map of reality that humanity has ever created. But we know, for a fact, that it's incomplete. It's a stepping stone to an even deeper truth. And the biggest, most exciting question in physics today is simply this: what incredible new things will the next map reveal?